When you have the sum of two logs in an equation, you can use the properties of logs to write them as a single log. Another aspect of solving logarithmic equations is that you need to verify you have no extraneous solutions. These would be apparent solutions that result in the argument of the log function being a negative quantity. Consider log base 2 of x plus 7 plus log base 2 of x plus 8 equals 1. Notice that we're adding two logarithms that have the same base. Therefore, we can write this as log base 2 x plus 7 times x plus 8 equals 1. Now, as is typically the case, when you have a log equation, you want to try and rewrite it as an equivalent exponential equation. Remember, y equals log base a of x implies a to the y equals x. So here, 2 to the first power is going to equal x plus 7 times x plus 8. What we're going to do now is multiply this out, and we get x squared plus 15x plus 56 equals 2. So in essence, what we've done is reduced our logarithmic equation down to a quadratic equation which we know how to solve. Subtract 2 from both sides of the equation. You get x squared plus 15x plus 54 equals 0. We can solve this by factoring. We factor this as x plus 9 times x plus 6 equals 0. Using the zero product property, we get that x equals 9, or, x equals negative 9, or x equals negative 6. Now what we need to do is see whether or not either of these are extraneous solutions. Don't automatically assume that because the value of the variable is negative, that the answer is extraneous. If we try negative 9, however, we notice that substituting negative 9 into this expression gives us log base 2 of negative 2. Because the argument of the log expression has to be positive, we know that negative 9 is extraneous, and therefore we exclude it from the possible solution. We can also try negative 6. We get log base 2 of negative 6 plus 7, which is log base 2 of 1, and the log base 2 of 1 is 0. Over here we have log base 2 of negative 6 plus 8 is log base 2 of 2. Log base 2 of 2 is 1. 0 plus 1 is 1, so negative 6 works. So our solution set is negative 6.
Now that we've solved this problem algebraically, let's see how we can solve a logarithmic equation on our graphing utility using our Smartboard interactive whiteboard. So we're going to solve the equation log base 2 of x plus 7 plus log base 2 of x plus 8 is equal to 1. We're going to go ahead and put this in our graphing utility. We're going to use our intersect feature. We'll use the left side of our equation as y1, the right side is y2. So in y equals, we're going to put in log base 2 of x plus 7 first. Now if we notice on our calculator, we only have two log bases that we can use. We have base 10 and base e. In this problem we're using base 2, so we need to use our change of base formula. We can use either base 10 or base e, which is the natural log, and we're going to prefer to use the natural log in this case. So we'll use the natural log of x plus 7, close parentheses, so we're taking just the natural log of x plus 7. We need to then divide by the natural log of 2 using our change of base formula. So this quantity, the natural log of x plus 7 divided by the natural log of 2 is equivalent to log base 2 of x plus 7. We'll do a similar thing for the second term. We need log base 2 of x plus 8. So using the change of base formula, we'll use the natural log of x plus 8 divided by the natural log of 2. Make sure you're closing your parentheses after the logs so that you're not taking the log of more than you want. So that was the left side of our equation. It's in y1. We'll go down to y2. The right side of our equation was just 1. So we'll enter 1 there. Let's take a look at that graph on our standard window. So here we have the graph of the left side of our equation. And there's the graph of the right side. We're looking for the intersection point of the two graphs. So we'll go to our calc menu, second and the trace key again to get to the calc menu. Pick option 5 for intersect. We get our usual 3 questions. The first curve is y1, so we'll just hit enter. Our second curve is y2, so we'll hit enter again. And then we need a guess. We're using a standard window, so each tick mark represents 1. You can see from this that our intersection point is somewhere around -6. So let's use -6 as our guess. And it turns out that the intersection point does occur at -6. The intersection point is -6, 1. So the solution to our equation is x equal to -6. And this verifies the result that we obtained algebraically.